Hello students, welcome to your introductory video to chapter 9. We're going to just take a few minutes and introduce you to quadratic functions and their graphs. This is essentially the first two sections of chapter 9 that we're just sort of squishing together into one, because we're going to do just a much more simplified version of it, because it is sort of a complex concept that I don't feel we can adequately discuss in this format. So we're going to do this sort of short intro video, and then we're going to go right into section 9.3, where we talk about quadratic equations and solving quadratic equations and what generally that looks like, okay? So what we need to understand is this term quadratic, right? This term quadratic is something that we saw at the beginning of chapter 8, when we classified polynomials. Okay, when we classified polynomials that had x squared as their biggest term, like degree 2 polynomials, we called those quadratics. Okay, so chapter 9 is going to be all about quadratic equations. So every equation that we see in chapter 9 is going to have a degree of 2, meaning x squared or some variable squared is going to be the biggest term in that polynomial. All right. So we're going to start, I'm just going to make a table of values for this particular function, okay, just like an input-output table. And I'm going to sort of show you what the graph of this most basic original quadratic function or quadratic equation looks like. And then I'll show you another example where it's sort of been shifted a little bit. And we'll just get sort of an understanding of what the graphs of quadratic functions look like. And then we'll move on from there into section 9.3 and so on with the rest of chapter 9. So if I just go over here and I start making myself a table of values for this particular equation, okay, y is equal to x squared. If I make my table of values with sort of our normal x values, normally we do -2, -1, 0, 1, and 2, just so we sort of get a vision of what's happening on either side of our 0, 0 point. If I plug this x value, -2, into the equation, and I do -2 squared, it is important that I put that -2 in parentheses, because otherwise the calculator, if you do it on a calculator, will give you the wrong answer. But -2 squared, again, means -2 times -2, right? Multiplied by itself. And -2 times -2 makes a +4. So I end up with this point, -2 in the x, +4 in the y, right there, okay? So that's my first point. If I plug -1 into this function, and I do -1 squared, -1 times -1 gives me +1. So my next point is -1 in the x, +1 in the y. That's right there. If I put 0 into this function, 0 squared is really 0 times 0, but 0 times 0 is still 0. So that's just right at the origin right there. Okay, so that's a y value of 0. And then if I put 1 into this function, 1 squared, 1 times 1 is 1. If I put 2 in there, 2 squared, 2 times 2 is 4. So what you notice is I actually get the same y values whether I use a positive or a negative x value. And that's going to be sort of important when we get to solving these equations. Okay, so I end up with this point here, 1, 1, and 2 goes up to 4 right there. Okay, so then I have sort of this shape. This is not a straight line graph, okay? Whoops, that's not going to work out very well. Let's see how well I can do this. That wasn't terrible. I thought it was pretty good. Okay, so what I end up with, you guys, is actually something called a parabola. Parabola, okay, a parabola. And a parabola is basically a U-shaped graph. And let's see if I can, I don't know how to do this. There you go, a U-shaped graph, okay? Where one side goes up, the other side goes up, and they go up symmetrically, okay, the same on both sides. There is a low point in a parabola, or if it gets flipped over, it becomes a high point. That is called the vertex, okay? So every parabola, every quadratic equations graph has something called a vertex. Okay, and the vertex point is simply the lowest point, or as I mentioned, if it gets flipped over, it's the highest point. Okay, so we could have parabolas that look like this, that go sort of down, and then the vertex would obviously be the highest point. But that's called the vertex, and that's sort of like a starting point for your graph. In the original, it's at 0, 0, but it's not always. Okay, it can shift around and move around. And then, yeah, this general shape is what every quadratic equations graph looks like. It doesn't matter how complicated the quadratic equation gets, the graph is always going to look something like this. Okay, so even if you have some equation like y equals 3.7 x squared minus 2x plus 20, this equation, if you were to put it on a graph and make a table of values, it would make a parabola that looks like this. Now, in this case, it would be a little bit skinnier. It would be kind of shifted around. The vertex would be at some random point in the coordinate plane. But it would look generally like a parabola, like this U-shaped graph. Okay, every quadratic equation has this U-shaped graph. If the number in front of the x squared is negative, so for example, if you have y equals, let's say, negative 3x squared plus 2, this graph, because it's a negative on the x squared, would be one that goes upside down like this, okay? And its vertex would be at the top. So if you have a negative in front, it goes upside down. If you have a positive number in front or no number in front like we have here, right here there's no number, so we just assume there's a 1, it's always going to open up like a U, okay? So that's the general shape of a parabola. Now if I go to a different example, okay, so this function is only slightly more complicated than the previous example, okay? This is still y equals x squared, it just now has a minus 3 on it. So if I make myself a table of values for this function, xy, if I go with my regular negative 2, negative 1, 0, 1, 2. If I plug negative 2 into this function, negative 2 squared is 4, and 4 minus 3 is 1. So I end up at this point right here. Okay, if I plug negative 1 in for this function, negative 1 squared is 1, minus 3 gives me negative 2, so I'm actually down here now. That's negative 2. If I put 0 into this function, 0 squared is 0. Minus 3 gets me negative 3. So I'm now down here at negative 3 on my y-axis. That is called my y-intercept. Remember, where we cross that y-axis is called our y-intercept. That's 0, negative 3. When I put x equals 1 in there, 1 squared gets me back to 1. And so this sort of goes back to the values I saw before. 2 squared gets me back to 4, and 4 minus 3 is 1. So I end up, again, your graph should look symmetrical on both sides of the low point of the vertex. So I end up with something like this. Sorry that I missed that point on that side again. But I have a parabola shape again, but notice here that I have not actually hit my vertex at the 0, 0 point, right? In this example, my vertex was right on the origin here. In this example, now my vertex is down here. Vertex is down here. Okay? And that's just because the entire graph has been shifted down by 3 spaces. So I've taken the whole graph and shifted it down. If I had x squared plus 3, I would do the same thing, but it'd be shifted up. So it would start up here at 3 and it would go up like this. Okay? Now this particular equation is one that we will eventually look at solving. This is one we could solve by square roots. And the last thing that I want to tell you in this intro video is when we get to solving quadratics, solving a quadratic equation, means finding the x-intercepts of the, oops, that's supposed to be a G. Oops, go back. Of the graph. Okay, so we'll talk more in our future sections about what a quadratic equation needs to look like, a certain form it needs to be in for us to solve it. But to connect it to these graphs that we're looking at, these parabola-shaped, U-shaped graphs, when we are asked to solve a quadratic equation, that basically means find the x values, find the values of x that hit this x-intercept, okay, the 0 points. So like this one and this one. Okay, and what I want you to notice is that this particular graph has two different x-intercepts. There are two values of x where the graph crosses that x-axis, right? Two different x-intercepts means the solutions, when we solve or find the solutions, we'll actually be finding two different solutions, okay? Two different answers. So just be prepared for that when we get into finding the solutions or solving quadratic equations. Oftentimes we're going to be finding multiple answers because these graphs sort of do the same thing on both sides, and so they can cross that x-axis two different spots. It doesn't mean that it always does, right? Up here we just would have one x-intercept and it happens to be 0, 0, but it could have two different answers, all right? So x-squared graphs, quadratic function graphs, always look like these parabolas or possibly upside down. And when we get to solving them later on in chapter 9 in our next videos, we're really going to be thinking about, well, we're not really be thinking about, but we're going to be finding the x-intercepts of the graph. Okay, and that's a way that we'll talk about solving by graphing a little bit. Just looking at a graph and deciding, okay, what are the solutions to this quadratic equation? And by that, we simply mean the x-intercepts, all right? So like I said, this was just a short introduction so that you know what a quadratic equations graph should look like, should you see it in the future. And that's all I have for you right now. We will begin with chapter 9 next week. And yeah, we will talk to you soon.